Now it looks like it's moving. Okay, good. So I'm David Martin. I manage the Industrial Partnership Program at Argonne National Laboratory and help do a lot of the planning for some of our collaborations that go on both now and in a lot of the future collaborations that we're planning for Aurora. The slides I've got here, I largely picked up from Susan Coughlin, who's the project manager for the Aurora system, and so the slides are approved by her as well, since some of the stuff that is going on with Aurora and some of our plans is still a bit confidential. To tell you a little bit about ALCF, so the U.S. Department of Energy funds 2 leadership computing facilities. So there's Argonne and one at Oak Ridge National Laboratory. The idea of leadership computing, which is a term I think only DOE really uses, is that it keeps a stable of the fastest machines that are kind of serial number 1 from the various vendors. And the idea is to keep some diversity of architecture and vendor and types of applications that are running. So I will talk a bit about what some of our current systems are and where we're going. So this is a list of the ALCF resources. Mira was a great machine and served us very well for quite a while. It ended in production at the end of last year. It ran a little bit more into 2020, but was decommissioned earlier this year and is now actually out of the building. So the system worked well. It was an IBM Blue Gene system that used a modified PowerPC processor. Our current workhorse is Theta, which is a Cray system running the Xeon Phi. It was deployed in 2017, and we've done a few little upgrades to it, but it's still our main workhorse. Most recently, we've added a machine called Theta GPU, which is really an addition to Theta, so it's sharing the kind of space and power, but the architecture is very different, and I will talk about that a little bit more, but it's using the GGX A100s that were just released by NVIDIA recently. So that is somewhat in production. We are still kind of playing with it a bit. And then Aurora, which will be an Intel Xeon system with GPUs coming soon. And I think many people have read in the press issues around Aurora delays. The only thing I can really say right now, and the only thing I really know, is that we are still talking to Intel about getting the machine as soon as possible and what mitigation we can do to get it pretty quickly. The other thing I wanted to mention, and I'll have a slide on this as well, is the Joint Laboratory for System Evaluation. This is a joint lab across several divisions at Argonne to test new equipment. And so I think there's 12 or 14 different systems that they have in place right now. I'll talk about a couple of those that are of importance to people who are targeting Aurora. So I said I'd mention a little bit more about Theta GPU. This is an Intel user group. I don't think there's much Intel hardware at all in this, but the reason I'm bringing it up is we think this is a really good test bed for starting to look toward Aurora and the type of architecture that Aurora will use, where most of the compute power, and 95% and above are produced by the GPUs. And so the current configuration of the Theta GPU nodes are 2 AMD Rome 64-core CPUs, a terabyte of memory, and the real workhorse again is the A100s, 8 of them in there. We've got some NVMe drives, a lot of capability to transfer to storage in between compute nodes. This was originally purchased with money that was allocated by the Department of Energy and the US government for doing COVID research, and that is still a major use of this, but it is slowly transitioning into a general use facility as well. And so if you have use for this, there are ways to apply through Argonne. I mentioned JLSC, so I thought I'd talk about it a bit for people who are interested in using those resources. There are a few systems that are of interest to people who are looking toward Aurora. The one that's most open and available right now is some nodes with Gen 9. The advantage of those is they look from an architectural standpoint, somewhat like the Aurora nodes will look. So they're available now for people to use. If you have a confidential NDA, so just kind of the first level of NDA, with Intel, you also get access to some of the Aurora SDKs. And those are kind of some specialized adaptations of Intel tools that are intended to work with the GPUs. We fairly recently got a little newer generation of the GPUs that Intel is developing, the integrated ones with capabilities to have higher bandwidth communications with the Xeon processors. The code name of those is DG1. And again, that requires an NDA with Intel to get access to those, but that's not too onerous a process. And so I encourage people, if you have the interest and the time, to start playing with those and looking at the development environment. So I'll switch on now to Aurora. You've probably seen some of these slides before. There's a little bit more detail filled in. We can talk about Ponte Vecchio now, the fact that there will be 6 of those on each of the nodes in Sapphire Rapids processors, linked together with a coherent memory structure. The big advantage of all that is that there will be really high bandwidth connections between the GPUs and the CPUs. And so we're expecting the applications to really be able to take advantage of that. We'll be using a Cray Slingshot network. And then, down toward the bottom, it's the Cray Shasta environment that I think a lot of facilities, including most of our sister laboratories at DOE, are using. And so we're putting a good bit of work into both testing and planning for Shasta and the integration of that. The programming model will support a good collection of those. The Intel One API is a priority for us, but people who use OpenMP or just LLVM with DPC++ and SYCL will all be supported on that. And next slide, to emphasize a little more the rich ecosystem of software that we're planning for this. We'll have a good set of compilers. We're doing a lot of work around LLVM to make sure that that's supported well for people who use that in the modern additions to C++ that it allows. We're also looking a lot at libraries, and in this we're a partner with the Exascale Computing Project to do libraries that will really scale in a heterogeneous CPU, GPU environment. So there's a lot of work going on around that, both testing. We have at Argonne Intel Center of Excellence that does a lot of work with us so that we can go back and forth with the developers in Intel quickly. And there's lots of frameworks there. I won't go through every one of those, but I want to point out that these are not all just simulation-based. TensorFlow is, for example, intended mostly for machine learning. And the idea behind the Aurora design is that it'll work well in the normal simulation environment, but it'll also work well for data analysis and machine learning. So the last thing I wanted to mention about Aurora and where we're going, I think Thomas did an excellent job, so I won't really go into why we need Deos. But we want to integrate the use of Lustre and Deos into our storage infrastructure, and I stole kind of the design about how the file system mounting points will look. And so that people can kind of start their applications running in just a normal Lustre environment that they're used to, and then slowly move to Deos as they start caring about small file performance, start worrying about burst things, and then even start picking up some of the object store semantics out of Deos rather than just normal POSIX file semantics. And we're really hoping that the MPIIO performs much better. Just a little bit initial simulation and testing shows that it should. And so we're kind of hopeful about that. So I think I'll stop here. If there are questions, after I finish chairing the session, I will go over to the chat in the discussion that we're having in the